Hello, everyone. Yeah, great to be here. My name's Krempel. I'm working at Cologne Intelligence as an Android developer. So this is, I guess, we saw a lot of business people, even though this is a developer track. And but I have to disappoint you, we won't be showing any code. Okay, just really quick, I'm a senior Android developer. I'm concerned with indoor navigation at the moment. I have experience with mobile augmented reality frameworks that you already heard about. Like, I think Wikitude is here, where we use their products already. And I have a personal background in machine learning, automated speech processing, and music information retrieval. So where do I work? Just to give you a quick impression, I'm working at Cologne Intelligence. We're a software developer agency, software development agency. We have several units for classic Java development, for business intelligence, consulting, and mobile apps, mobile applications, native mobile applications, to be precise. Yeah, and we're working for different customers, and big ones, small ones. And yeah, this is our main business. But now let's move on quickly to indoor navigation. It may be the case that you don't know what indoor navigation is, but I think you get the image if you look at something familiar. Who has not used Google Maps? Nobody, half. Okay, there are a lot of, I think, everybody knows navigation systems from the outdoor use case, and there are a couple around which are really powerful. There's Google Maps, Apple Maps, there's Here Maps, there's OpenStreetMaps. So we have bright varieties of products in that area, and mostly they can do the same. They just don't just show your position on a map, but they can route you, offer you alternative routes to go, show you even live traffic information, which is really a nice feature. And you can get additional information like local restaurants or gas stations, whatever you may need. So how does it all work? In order to have a routing, like in my car, like in a navigation system, I need a GPS connection. And the problem of indoor navigation is that GPS doesn't work reliably indoors. So that's the main reason why we don't have an indoor Google Maps already. So the task could be described as to find a suitable route from my position to a destination inside a building. If we look at these separate components, first, I need to know my position. I can tell Google Maps, okay, I'm here, but that's approximately, and it won't work too good. An automatic solution is better, and we need an indoor positioning system for that we not yet have in such a standardized way like we have in GPS. I have to find out where do I want to go. I can tell the system via a user interface of some kind. That could be a speech, it could be a touch screen or a keyboard or whatever you might imagine. And this user interface is also important for showing me, for guiding me along the route. Where do I have to go? Do I have to turn left, turn right? And there's a couple of form factors and possibilities for that as well. So you could have turn-by-turn instructions. There are even vibrating handlebars for bikes. So it vibrates on the left if you have to go to the left, vibrates on the right if you have to go to the right. So there's a lot of things thinkable, but let's move on. In order to calculate the correct route within a building, I need additional information. And the system has to store this additional information in an abstract form, in a very, you can imagine there are several formats available. You could use XML or some other markup. You could use plain old Java objects or whatever sort of data structure you may like. But you have to store where are the rooms, how big are they, where are the doors, where are the walls, where are maybe points of interest where I want to go, where are the stairs, where can I change levels, and all this information. So, and the next thing which I think is really important is the suitable route may depend on the user group. So there are people, well, not the shortest route is the best route for everyone. It all boils down to these 4 basic questions, like who am I, where do I want to go, and how do I get there? So far maybe some of you think, most of the time I can find the coffee machine on my own, so I don't need it in my home. I don't need to know an automated system to show me the room, the route to my kitchen or someplace else. So think again. If you're in a shopping mall, it might be a real valuable information because it saves time to find the right product. Where is that at? Why can I look at that? And from the shopping mall's perspective, it's also a very interesting information to know which routes are my customers taking and which are the routes that are frequently used. Another possibility is the situation where I don't know upfront where I want to go, but maybe I know where what am I interested in. I want to find a specific book, for example. And if you try to figure out in which of these shelves a specific book like Treasure Island, for example, is, you could spend a lot of time searching if you don't have any automated assistance. We could move on. There's more use cases thinkable. For example, you could take a boat cruise, but you could also use big hotels, big buildings of any kind. Maybe if you're the federal district, if you're Bürgerdienst, how do you call it? Doesn't matter. Official buildings where you have services, like you need to register your new car or stuff like that. If you want to find in which room do I have to go in this 50 storage building, it might be helpful. Okay, let's talk a bit about user groups, because not everyone has the same needs. For example, elderly people or children might get disorientated more quickly than the regular adults. There are people who cannot, who are visually impaired or handicapped in another way, that they need special assistance. For example, we see a map for blind people where you can feel the structure. Okay, this is outdoors, and it wouldn't make sense for indoors, I guess. But I think you get the idea. People that rely on a wheelchair need a special route. They cannot use stairs. They have to use lifts. But as we are on an augmented and virtual reality congress, there's something more to that. Imagine when you have a VR headset on, you don't have any idea how to orient yourself in the building that you may know already. So there is a solution in some systems that show you a grid when you're moving near to a wall. But this only works in small rooms. And the use case has also a dimension of scale. So I can do, there exist solutions which are pretty precise for small rooms, like built in the headsets already on the market. But if you think of this building that we're in at the moment, it's got a lot of rooms, and it's got a lot of, it's got three levels. And imagine walking around here with a VR headset on, and I don't think you will arrive at your destination safely. If you think of robots, okay, this is the, I think you get the idea that without an automated route calculation, a robot doesn't know where to go, because there's no other way of telling. So what do we need to know in order to supply a valid indoor navigation? First, we need to know our position. You're not here, because this is Andromeda. That's not the Milky Way. Okay, there exist a couple of technologies which are used on a broad scale, but that don't work. You cannot use GSM cell localization or GPS satellite connections because they don't work indoors. Or the precision is not high enough because a GSM cell can vary between, I think, 3 kilometers and 45 kilometers. So the info isn't precise enough. So for those of you who don't know what's this called in English, in German it's a Leuchtturm, in English it's a beacon. So, and there's a product called iBeacons that we can, that are one possibility of tackling the use case of indoor positioning or the challenge. On the technological side, they look like this. This is just one brand. I didn't want to put up 25 different beacons. It's not a recommendation which vendor to use, but basically they cost about $20 to $30 each, are a small device, are powered mostly by battery, and depend on Bluetooth LE, so Bluetooth low energy. The battery life is between 1 year and 5 years, but you please keep in mind that somebody has to change that battery at some time. Another possibility would be Wi-Fi. With a technique which I'm going to explain later, you can create a database of available Wi-Fi networks and thereby do a location which works depending on how many different Wi-Fi networks are available, pretty good. If you're in a rural area where there's about 20 or 30 Wi-Fi networks available, then you can really do precise positioning with that. But when there's no Wi-Fi, no position. Okay. While these were more like the technological parts of the problem, what I want to do here quickly is explain 2 approaches to tackle this problem. On the left, you see the fingerprint chart of Al Capone. I put it on because what I just described with the Wi-Fi networks is called a fingerprinting system. So you have a set of features, which may be Wi-Fi networks available with a signal strength, or maybe beacon levels detected by a smartphone, or the air pressure, sunlight, whatever you like. You need a couple of features, and you build up a database of places. So, for example, you walk around in this room, and each meter you take a recording. Okay, this Wi-Fi is at strength 90, and if I move 1 meter ahead, it has a strength of 80 decibel. So, what's going on? The problem is here. It has to be distinct. It has to be unique. In order, there may be places where it gets mixed up because the features are similar, and it's not guaranteed to work under all conditions. And if these data changes, the system is useless. It doesn't work anymore. Another thing which has been in use for a really long time is triangulation or trilateration. And just to prove that it's been around for a while, I tried to find an old picture of it. I think most of you know how that it's there and maybe how it works. Basically, you calculate an unknown position by 3 or more known positions, and by measuring the distances between them, which would be trilateration, or the angles between them, which would be triangulation. And by that you can create 3 spheres, and just in the middle where they all overlap, there's your position, just to put it simplified. Okay, so far for indoor positioning, to answer the question, where am I? The next step would be, okay, I know I'm in room 2 at DIGILITY at Cologne Congress Center Nord, and I want to go to the coffee machine because I missed the coffee break, right? How do I get there? This works a bit different when I'm outdoors than when I'm indoors. What you see here is a maze, and this is pretty much like it works when you're outdoor, because you only have the choice, okay, do I go left, do I go right? You cannot, you won't walk through the walls. You wouldn't do that. It's just like in a car. You wouldn't go freely through, just leave the road and move over the field, but you always take the turns. When you're indoors, you have to think another way around, because it's more like walking freely, and there are obstacles in your way where you cannot move. So the first thing, this could be solved by defining a network of routes, of possible routes, and then calculating the shortest path. You have to think in another way when you're dealing with indoor location, and so you have free motion and it gets blocked by obstacles. So what I need to create this route is I need information about the building, which would be, the term for that is the building information model. Just two examples how this could look in a traditional way. So you have a museum map, a room plan, you have the different rooms, you have the stairs, and extra information. This is pretty much what we are used to when navigating on maps. And I really think this image is quite interesting, because this shows an office in, I think it was Karlsruhe, and what the architects did while doing this concept, they made a little paper model of each desk and each file cabinet and each table and each plant that was to be in the office. So, but this is pretty much what we need in information to do an indoor navigation. The question of where you want to go has two dimensions: picking my destination and getting guided along the route. And this sign is taken from a crossing which is called Confusion Corner. And I think you know why. And this would be bad interface design from my point of view. Okay, I don't want to talk much about interfaces. I guess most of you can imagine what possibilities there are. Okay, we did a couple of beacon projects, because this is the only technology, which is available to all smartphones. Like it works on iOS, it works on Android, and we did a couple of projects there. And let me share some experiences that we had. In order to do navigation by beacons, you need to set up a beacon grid, which you can think of as, just look at the access points and the fire alarm, sprinkler things just up there. And similar to that, you would have to put up a beacon like every 3 meters. If you talk to the specialists, they say about for 100 square meters, you need 8 beacons. And you can do the math. One beacon, $30. It's not so cheap. Okay. This is a pretty bridge, but that's not the reason why I put it up there. It's lit up for Christmas with 4,000 light bulbs. And if you think of in scales of maybe an airport, you would need just as much beacons. So, and please remember, somebody has to change the batteries. And you have to have some back-end structure where, just imagine, okay, I will start my working day, and I will take out one light bulb, write down a number into your computer, and put it back in. So I guess it will take some time until I'm done with 4,000 light bulbs. And you have to do this all the time, because they go broke, you have to replace them and stuff like that. So there's a lot of maintenance costs involved when using beacons. Another problem is precision. The precision depends on how dense you create your beacon grid. So if you put more beacons in it, you get better precision, but more maintenance and more setup and more configuration. The approximate precision that you get using beacons is about half the distance between the nearest beacons. So if your beacons are 2 meters apart, you get 1 meter precision, which is, for a 2D indoor navigation, might be enough, but if you want to do augmented reality indoor navigation, it won't work. It's not precise enough. Another thing is, when you're developing such an app, testing is an issue because it burns calories. There are no automated regression tests for an indoor positioning system. Somebody has to take the device, connect it to a laptop, and walk around the whole structure and check, is it still working? Beacons have another problem, which is the one of interference and reflections. What you see here is a reverb chamber, which was used before there was digital effects in audio processing. So there's a loudspeaker on the one side, and there's a microphone on the other side, and you just play back your sound, and then it gets reverb, and then you record it again. So all these early Elvis Presley recordings were done with echo chambers or reverb chambers or plates. So, and the problem is that when you have that the reflections of the Bluetooth technology, they really depend on which materials are built into the building. So if you have a lot of steel, or have glass, or have wood, or have stone, it's all different, and it's all affecting the levels that you get from the beacons. No system is perfect. This is a sign that the inhabitants of a small town put up because there was a glitch in GPS which led all the visitors that were searching for Mount Rushmore in the USA to a small town a couple of miles, or I don't know the exact distance, I would have to look it up. But you get the idea, it doesn't work always. And so that's a problem. But you have that with each technology. So what could change this whole field or this whole use case is a technology called Google Tango. Who has heard of Google Tango? Who has seen demos of Google Tango? Okay, yeah. Just before I forget, we're having a workshop tomorrow, and we have Tango devices with us, and we will show all of you who have not seen this technology. You can look at it, and we will show some applications that we did with it. Okay. What's so cool about Google Tango? Let me give you a quick introduction. It's a technology from the Google ATAP division, Advanced Technology and Projects. And it extends a given Android device with additional cameras and additional sensors. So that way, Google Tango can gather additional information on the environment. How it works? It makes use of sensor fusion. So you can, what you see on the left is an inertial measurement unit, an IMU.
3 minutes left.
Wie viele?
3 Minuten noch.
Okay.
But with the questions from the audience, so.
Okay.
Otherwise, you don't get your coffee.
Ah, that's nice.
I'm a good listener.
Much. Okay. Let's wrap it up. We have sensor fusion and dead reckoning and visual odometry, which are techniques used by Google Tango to do an exact precise position. So what we did is we did a research project and created an indoor navigation, and we created it of this building that you're in at the moment. We went early and were here yesterday and trained the building, so you can try it out, and we will demo that tomorrow in the workshop. This is like the 2D perspective, and it really shows how precise this is working. We're talking about centimeters, not meters. The cool thing, or bad thing, is it's dependent on light conditions. So bright sunlight and transparent surfaces and mirrors don't work so well, so it's kind of a vampire, or whatever. The most important thing is it doesn't have no infrastructure, it's working on data only. So, and this means it's a real game changer, and it will, if this technology goes into the mobile devices that each of you carry around with you, it will definitely make indoor positioning on a centimeter grade available for all public buildings at least. So, okay, we don't have time for that. Let's talk about complete navigation. Complete navigation is the use case. I want to navigate from here to my hotel room in Shanghai without any interferences or restrictions, or any other place on the planet. this is something that Google Tango can be a solution for, or while the other technologies cannot, because nobody is going to put up a beacon grid everywhere in the world. But you can train the rooms on a data-only basis with your Google Tango device, if enough people carry it around. So, and why are Google interested? Because of data. So, I don't think we will see many of drones or Google cars, because the users themselves are going to create the data. And if you take this a couple of years in the future, I guess a central part of Google Maps will be a precise meter or centimeter grade indoor navigation available for everyone. Thank you.
Woohoo. Well, lucky you, I'm one of the weird persons who are not into coffee, and that's why you can still have that one.
Thank you very much.
Thank you so much. But I think when we have questions for you, then please address them tomorrow at the workshop, which is at 1 p.m.
I think so, yeah. If you didn't change the schedule,
let's see,
it will be like
1
that.
p.m., 1 to 3 p.m.
Nice.
So,
Okay.
thank you so much.
Thanks, bye.